Hey, greetings everyone. Here is your next video on the topic of solving exponential equations. So just a quick little review before we get into things, just trying to connect what we've been doing. We know what exponential equations are if we were to graph them. Okay, we could have something like this, and it's going to be the equation would be in the form of a times b to the x. Okay, and depending on what A is and what B is, the most typical type of equation that we see is something like that. Okay, so we're going to look at two different equations. They're going to eventually have a common base. Now, the type of problems I could ask up here, they get a little bit more complicated. We actually don't know how to solve them yet until we look at some things later this week and into next week. We're going to look at questions like this. I know that might look a little intimidating right now, but our goal is to try and make these things have common bases. So if we look at this, we don't really know what 5 to the 3x minus 2 power would look like. The fact that the base is 5, it probably would look a little bit like what's going on in green there, but it might be stretched a little bit or shifted left or right. There's just some other things that we can't quite graph up here. And our goal is to maybe think a little bit about what this other equation might look like. Now it looks kind of complicated right now. In fact, in the end, this is just going to be a number, but because there's just a power right here, or just a normal number. But if there was anything involving an x here, that would be a little bit more complicated. So we have to be thinking about that as well. But let's just pretend there was an x there. It's going to be some sort of a function. It's going to be doing something like, I don't know, maybe something like that. And in these kind of problems, what we're really trying to do graphically is we're trying to figure out the x value where they would cross. Okay, that's our goal. It just gets a little tricky how we get there sometimes. Okay, so if we were to solve this particular problem, okay, our goal is to figure out how we can make the bases be the same. So the fact that this one already has a base of 5, I'm going to kind of work with that initially. I want to try to think about how I could write 3,125, how I could write that as 5 raised to a power. So this is going to take some calculator work. I can't show you the calculator on the screen right now. I actually am looking into a program that I think is free right now. I just haven't downloaded it. But on my calculator, I'm just going to go 5 to the 5th and figure out what that is. And that actually ends up being 3,125. So that was kind of a lucky guess to start out. Okay, so if I start out with 3,125 raised to the negative 1 power, and that's going to equal 5 times 5 to the 3x minus 2 power. What I just did on my calculator was I figured out that this number right there is actually 5 to the 5th. Okay, so that's 5 to the 5th. But it's still raised to a negative 1 power. And over here I haven't changed anything. Okay? And then we just did an assignment last week that dealt with the left side. If I have a power raised to a power, what we learned in that assignment was we actually multiply them. So 5 times negative 1 is negative 5. Okay, and now if we have this thing kind of worked out this way, we have negative 5. 5 to the negative 5th power equals 5 to the 3x minus 2 power. The only way that that's true is if the powers are equal. So now I'm going to drop the base of 5, and I'm just going to deal with the powers. Okay, so I just need to solve. Now this kind of turns into a problem from like linear algebra sort of, where I just move the pieces around. So I'm going to add 2 to both sides. Okay, that means I get negative 3 over here. Is going to equal 3x, right? Add 2 to both sides. That's a divide by 3. When I do that, I get x equals negative 1. If we want to write it like this, that's fine too. So if I were to go on my calculator and go back to the original problem here, right up here, and if I were to put in a negative 1 right there, I think that was our answer, right? And I go 5 to whatever power I get there, and I do 3,125 to the negative 1 power. I should get the same answer for both. So that's kind of what we're trying to do, is to figure out what's the value of x that makes this statement true. Okay, so that was one problem. It's kind of a level 1 problem. Remember, if you get stuck, you will find an example problem up here. Okay, it's going to look a little different than what my screen does because this is the teacher version. One thing I was going to mention is at this point there are no videos for this particular topic. Now, the person who is in charge of this program, he is making new videos every single day. So it's possible by the time you guys get to this, there might be some videos posted there. But you have my videos here that you can always look back on if you need that extra help. Okay, so let's look at one that's maybe a little bit different, a little bit harder perhaps. Okay, so the issue here is now we don't necessarily have a common base. We have 128 and we have 16, and we might need to make both of them smaller. So the fact that 16 I recognize as 4 squared, I'm going to see if there's a way that I could get 4 to a power to equal 128. So I'm going to go back to my calculator again. If I go 4 to the third, I get 64, and 4 to the fourth is 256. Well, I wish that was a little bit nicer. If I did 4, I see what we would do here, I think. Yeah, let's try to do 2's. Okay, so 16 is 2 to the fourth. Okay, 2 to the fourth. Okay, so I'm going to try to get a common base of 2. So if I did 2 to the, we'll do 6, we'll say, that's 64. Okay, so 2 to the 7th is 128. There we go. Okay, so here's what I figured out by doing this. Okay, I know if I write the original here, 128, 4x plus 14 equals 16, and 3x minus 13. Okay, what I know is that 128 is now 2 to the 7th. It's just some guesswork there. Just have to try some things. Okay, the 16, that was 2 to the fourth. So 3x minus 13 on the outside. Okay, so the difference between the first example and this example is now I have to do this on both sides, and now on both sides I have a power raised to a power. Okay, so if I were to go 7 times 4x plus 14, my base would still be 2, but I would have, what, a 28x, and then 7 times 14 is 98. Okay, and that's going to equal a base of 2, and then 4 times 3x minus 13, so I'd have a 12x minus, and that would be 4 times 13 is 52, I believe. Okay, so based on all of this, okay, what I know is the powers have to be the same. That's kind of the key thing for this particular lesson. 28x plus 98 has to equal 12x minus 52. Okay, so I need to get, I just need to solve this linear equation. So I'm going to subtract 12x from both sides. Okay, I'm going to subtract 98 from both sides. Okay, so if I do that, let me go back to green here. Let's see, I would have 16x equals negative 52 minus 98, that would be negative 150. Let's make sure I did everything right there. I think I did. Okay, so to get what x equals, I need to divide 150, or negative 150, by 16, to get 9.375. So negative 9.375. Okay, so hopefully that would be the right answer for this particular question. Just kind of quickly looking at it, I don't see any issues that come up there. So hopefully that makes sense to you guys too. Okay, last example. Okay, they have what they call level 3 here. And just so you know, I think level 1, level 2, I think that's kind of the main thing that I would be looking for. But I'm going to ask you to try a couple from level 3. I think it's good practice for you. And yeah, I think this is still pretty useful. So for this one, you see a 1 over 6 as a base and a 36 as a base. The emphasis here is one of them's, at least one of them is going to be a fraction like this. Okay, and you might have to stare at it for a little bit. You might have to try some things on your calculator, but I think in this case it's pretty easy to see our base is probably going to be 6. Okay, this is 6 to the negative 1. This is 6 squared. So again, if I were to start with the original, okay, so I have 1 6 raised to the 3x squared minus 15x. Okay, that's another change for this particular level, is now all of a sudden in the powers we have things that are being squared. That might be a little new for us. Okay, and then I have 36 to the 12x plus 3 power. Okay, so what I was talking about was we want to have the same base. So this I can write as 6 to the negative 1. If you're not quite sure about that, make sure you ask. I feel like a few of you, as we were going through that particular lesson, maybe did not ask a question when you should have. Okay, the 36 is a 6 squared. We still have 12x plus 3 right there. I think everything's good there. Now I need to, if I have a power raised to a power, I need to multiply those things together. So I would have 6 to the negative 3x squared plus 15x is going to equal 6 to the 24x plus 5. Okay, and just like we did before, what all of this means is that the powers now have to be the same. The bases are the same, so in order for them to be equal, negative 3x squared plus 15x has to equal 24x plus, oh, let's see, did I make a little mistake there? Quick say I'm done. I did. Why didn't you guys tell me this? Okay, so here's my mistake. Let's catch it. Right there, I should have multiplied. I didn't multiply. This should be a 10. I should have shouted out or something. Okay, so this is going to be plus 10 right here. Okay, so now I need to figure out how I solve and show that these two things are exactly the same. Okay, so for this, ideally I would have, this is going back to what we kind of just wrapped up right before this little break here. I need to get one side equal to 0. We're solving a quadratic. I really want that 3x squared to be positive, so I'm going to move everything to the right side. Okay, so I'm going to have 0 would equal 3x squared. If I'm going to subtract 15x from both sides, that means I have a 9x left over, and I'm going to be adding 10 to that. Okay, again, hopefully kind of doing everything okay here. So now I have to figure out how I would solve this, and we have a lot of methods. We could factor it. We could do quadratic formula. We could do completing the square. All these things are fantastic ideas. I think I'm just going to do a very quick review. Let's see here if I'm looking at this. This is where it's nice. On some other programs I use, I can pause it if I'm not quite sure the best route to take here. I'm almost a little nervous that this might give us some bad answers, so I think I'm going to try quadratic formula here. Okay, so to do that, we would say x has to equal, that'd be negative b, so negative 9. Okay, plus or minus the square root of b squared, so that's going to be 9 squared, which is 81, minus 4 times 3, the a times c times 10. Okay, all divided by 2 times a, so 2 times 3. Okay, I'm just going to simplify that. So I have negative 9 plus or minus the square root of 81. Let's see, 4 times 3 is 12. Oh boy, what did I do wrong here? 12 times 10 is 120. That makes me a little nervous, guys. all over 6. And the reason I'm nervous, if you haven't caught it yet, okay, there's an issue right there. So I'm going to quick look at the solution here. Let's see, did I make a mistake somewhere? I must have made a mistake somewhere along the way. See, this is good practice. Oh, I copied down something down wrong. Oh. I'm sorry, guys. I hope I didn't confuse you too much here. I don't think I'm going to necessarily remake the video, but yeah, I probably just spent a couple minutes here where all of a sudden things are not going so well. It's a simple mistake right around here. So you guys probably saw me make my correction right there, and you're like, no. So I guess that's maybe a valuable lesson here. I'll just say I did that on purpose, because if I had done something wrong, if I had put an answer in, go back to the question, if I had put an answer in here and it popped up as wrong, you might have another chance to try it again. But then if you got it wrong a second time, they're going to show you that answer. And if you have your work written out, then you'll be able to kind of try to figure out what went wrong and how you need to fix it. So one thing I am going to be requiring is that you are showing your work. I should have mentioned this at the very beginning. You are showing your work. You are putting that work, taking a picture of it eventually. You're going to put it into Google Classroom. It's going to allow me to see it. I can write comments if I need to. Right on there, and you'll get some feedback from me. So for this particular one, I kind of made a mistake, but maybe that's still a learning opportunity for us as far as how we can fix it. So in the end, if you caught that early on and you are looking for the answer would have been -1 and -2. And this whole thing, solving it, we would have done it by factoring, because you would have been able to factor out a 3, and you would have had a much easier thing to break apart. And I think everything that's on here, it should be easy to break apart.